What are the biggest challenges debugging embedded hardware-software interactions? Imagine trying to fix a puzzle where some pieces are hidden, some are moving, and others are invisible. That's what debugging embedded hardware and software interactions often feels like. When working with microprocessors in digital electronics and embedded systems, several hurdles can make troubleshooting a real challenge. First, many embedded systems have limited visibility into what's happening inside. Unlike a personal computer with screens and extensive debugging tools, these devices often lack detailed displays or interfaces. This makes it tough to see what the hardware and software are doing at any moment. Without clear internal signals, pinpointing where a fault occurs becomes a guessing game. Next, the integration of hardware and software is very tight in embedded systems. Microprocessors, memory, and peripherals all work together in a complex dance. Bugs can come from timing issues, signal noise, or incorrect assumptions about how hardware behaves. Debugging requires understanding both the electrical signals and the software code at the same time, which can be tricky. Real-time constraints add another layer of difficulty. Many embedded systems need to respond instantly to inputs or events. If you use debugging tools that pause or slow down the system, it can change how the system behaves. This can hide the real problem or create new issues, making it hard to reproduce bugs reliably. Resources are often limited in these systems. Microcontrollers and embedded devices usually have small amounts of memory and processing power. This means you cannot add heavy debugging routines or extensive logging without risking performance issues. Developers need to find a balance between gathering enough information and not overloading the system. Accessing hardware signals is also more difficult than in traditional computers. Many embedded systems use system-on-chip designs, which combine multiple components into a single chip. This reduces physical access points for tools like oscilloscopes or logic analyzers. Probing internal signals becomes more complicated, requiring specialized equipment or techniques. When multiple processors or modules are involved, debugging gets even more complex. Interactions between different cores or shared resources can cause unpredictable behaviors. Isolating the source of a fault requires sophisticated tools and careful analysis of concurrent processes. Remote deployment adds another challenge. Embedded systems are often placed in hard-to-reach locations like vehicles, factories, or aircraft. Connecting debugging hardware or performing physical inspections isn't always possible. This makes remote debugging and error reporting essential but more difficult to implement. Finally, the lack of standardization across different hardware architectures and development environments means that debugging tools and methods are not always compatible. Engineers often need to adapt their approach for each new platform, which can slow down troubleshooting. To tackle these challenges, engineers use a variety of techniques. JTAG interfaces and in-circuit emulators allow hardware-level debugging without stopping the system. Embedding diagnostic routines or lightweight logs helps capture system states during operation. Simulators and emulators can mimic hardware behavior before deployment, catching issues early. Modular design and unit testing isolate problems to specific parts, making debugging more manageable. Post-mortem analysis of crash dumps helps understand failures after the fact. In the end, debugging embedded hardware-software interactions is a balancing act. It requires clever use of tools, thoughtful design choices, and patience. By understanding these challenges, engineers can develop more reliable systems and solve problems more efficiently.